In this video, we're finding real zeros of the polynomial f of x equals x to the 6th power minus 9x to the 4th power. The direction is to find the zeros for the function and state the multiplicity of each zero. So in order to do that, we will factor this polynomial first, okay? So f of x equals x to the 6th. I'm going to highlight the exponents here, okay? X to the 6th and x to the 4th, okay? What is the greatest common factor? What can I factor out from x to the 6th and x to the 4th? Okay, that will be x to the 4th. So watch, we're going to get f of x equals, pull out x to the 4th out to the front. Inside the parenthesis, we will put x squared minus 9. Now you can, when you factor it, you can always distribute it and see if they add back up to the original expression. So if I do x to the 4th times x squared, that will give us x to the 6th power. And x to the 4th minus 9 will give us 9x to the 4th. So first thing was to factor out the GCF of x to the 4th. But now notice that binomial right here, x squared minus 9, that's difference of perfect squares. Let's break that down this time. So that expression will now break into x plus 3 times what? X minus 3, right? So we got f of x completely factored out, okay? We got 3 factors. I'm going to highlight those, okay? So the first factor that I see is x to the 4th power. The second factor that I see is x plus 3. And the last factor that we see is x minus 3. Using these 3 factors, let's find all the zeros. So here are the zeros. Zeros are x equals. Now, when is that x minus x to the 4th equals 0? You can take 4th root of both sides or just realize that when x is 0, x to the 4th is equal to 0. Now, let's talk about the multiplicity though. Notice that this function or this 0 has an exponent of 4, right? So we'll say x equals 0 with multiplicity 4. Next one, what is the 0 from this one? When x plus 3 is set equal to 0, we can say that the second 0 is going to be x equals negative 3. Notice there's no exponent written, so that factor must be raised to the 1st power. So we'll say with multiplicity, just 1, or no multiplicity. And then the last one, the last 0 is going to be positive 3 by setting x minus 3 equal to 0. And again, when there's no exponent explicitly written, we know that's just raised to the 1st power. So if you can say just with multiplicity 1, then we found all zeros and stated the multiplicity of each 0 here.